All right, let's talk about Python. Specifically, let's get into the Code Organizer's Guide to Python. Because if you've ever written more than a few lines of code, you've definitely absolutely run into one particular error that can drive you crazy.
You know the one. You're deep in the zone, everything's flowing, and then, boom, name error. It tells you a name isn't defined, but you're staring right at it. You know it's in there somewhere, so why can't Python find it?
Well, here's the twist. That annoying error, it's not a bug. It's actually a super important feature. It's all part of how Python keeps everything organized in what you could call its own secret filing system. And today, we're going to pull back the curtain on exactly how it works.
So let's get right into it. Welcome to Section 1, Python's secret filing system. To really get a handle on this, we need to talk about two fundamental ideas, namespaces and modules. First up, what on earth is a namespace? Okay, picture a giant office building. A namespace is like the phone directory for just one department in that building, say, the sales team. It's a complete list of every name, every variable, every function that belongs specifically to them. It keeps their stuff separate from, say, the accounting department's directory down the hall.
So, if the namespace is the directory, what's a module? Well, in our analogy, the module is the department itself. In your code, it's just a Python file. That's it. You might have a calculations.py file and a user_profiles.py file. Each of those files is its own little world, its own self-contained module. And here is the crucial takeaway. Every single module gets its own private namespace, its own phone directory. This is why Python is so powerful. It means you can have a function called getData in your user profiles module and another totally different function also called getData in your calculations module. Python never gets them mixed up because they live in different namespaces. This is how it avoids what programmers call name collision.
Okay, so we've got these separate little worlds. But when you ask for a variable, how does Python know which world to look in? That brings us to our next section, the rules of the room, or how Python actually finds your stuff.
This is where we run into the idea of scope. And it sounds technical, but really, scope is just the set of rules that tells Python where it's allowed to look for a name from any given point in your code. It defines which directories it has access to. Understanding this is the real key to solving those name error mysteries.
And here's the most important part. Python is not random. It doesn't just look everywhere at once. It follows a very strict, very predictable search order, kind of like a detective, methodically checking specific locations for a clue.
And this is that exact search path. First, Python looks in the local scope. That's the room it's currently in, the code inside whatever function is running. If it doesn't find the name there, it takes one step out and checks the global scope. That's the main area of the current file or module. And if it's still not there, it checks its last resort, the built-in scope. This is like the foundation of the entire building where all of Python's core functions, like print, live. Only after it has checked all three of these places in this exact order and comes up empty-handed, that's when it gives up and tells you there's a name error.
So now that we get the theory, let's make it practical. How do we actually use this system to our advantage? That brings us to putting code in its place and using modules to get organized.
This is where you become the architect. A user-defined module is not some scary advanced concept. It is literally just a Python file you create to hold related stuff. When you group all your user authentication functions into one file, you're creating a module. You are building your own namespaces. This is the leap from just writing a script to actually engineering a proper application.
And once you get comfortable organizing code into modules, you unlock one of the most powerful techniques in a developer's toolkit. Let's talk about the art of refactoring, cleaning up your code like a pro.
So what is refactoring? Simply put, it's the process of changing the internal structure of your code without changing its external behavior. The program does the exact same thing it did before, but on the inside, it's cleaner, more logical, and way more efficient.
I mean, just look at this. On the left, you've got the before. It's one giant, messy script where your main logic and all your test code are just jumbled together. We've all written files like that. But on the right, the after. It's beautiful. You have a clean main.py file that just runs the app and a totally separate test main.py module that only handles testing. Which one would you rather work on?
And the whole point of doing this is to make our lives easier.
You refactor to improve readability, so you can actually understand your own code 6 months from now. You do it to simplify the structure, breaking a huge problem into smaller, solvable pieces. You do it to remove redundancies, the classic don't repeat yourself principle. And all of that rolls up into the ultimate prize, enhancing maintainability. It means your code is no longer a house of cards, but a solid foundation you can build on.
Okay, so let's zoom out. Why is this so important? Because understanding namespaces, scope, and refactoring is the dividing line. It's what takes you from just writing scripts to truly building systems.
And here's the real secret. Clean, organized code isn't just about being neat for the sake of it. It's about being powerful. It's what allows you to tackle bigger, more complex problems without getting tangled up in your own logic.
I mean, the source material really nails it with this quote. The whole point is to improve the code structure, its readability, and its maintainability. That right there, that's the core of professional, sustainable software development.
So I'll leave you with a challenge. Open up a project you're working on. Find just one part of it. What's one big function you could break down? Is there a group of related variables you could pull into their own module? What is one single thing you could refactor today? Give it a try. You might be surprised how much of a difference it makes.